I hope you're having a great day because I bet this will make it at least 1,000 times better. This is the Unit 5, Lesson 14 homework with Obvi's me, Miss Bellman. So we're going to write an inequality for these numbers, 1 and 2. They're in word form, and we're going to take them and we're going to write an inequality. So 10 minus 7 is less than 5. So I'm going to write it 10 minus 7 less than 5. I could also solve this by saying, well, not really solve, but check my answer and say, oh, you know what? That equals 3 and it is less than 5. We're going to be looking at 4 different symbols. Less than, what we just saw, greater than, which is the opposite, and then 2 others, being less than or equal to, or greater than or equal to. When we have a less than or equal to, or a greater than or equal to, that means that they have half of an equal sign underneath the symbol. It does change it. It's meaning that, hey, this number could be equal to this, or it might be bigger, or it might be smaller. The cool part about inequalities is that they have an infinite number of answers, whether you're looking at the left or the right. So m is greater than or equal to 25. Again, reading left to right, m is greater than or equal to 25. Sometimes it's cool to be able to check it when you have just numbers, not necessarily variables without what they stand for. So we're going to do the opposite of what we did in 1 and 2 and write the inequality in words. So 8, and I could look over at my 4 options that I have, and that symbol is the greater than symbol. So 8 is greater than 25 divided by 5. I could actually check my answer by saying, what's 25 divided by 5? Okay, well that's 5, and 8 is actually greater than 5. If you didn't know that, hey, I'm glad I got to tell you 8 is greater than 5. And if you did, I'm high-fiving you right now. Good job. Number 4, 9 plus 5 is less than j. So when we write this out, we could do 9 plus 5. I could say the sum of 9 and 5, but I will just say 9 plus 5 is less than j. If you flip the symbol, or if you're looking at it and you write the symbol incorrectly, you could change the complete meaning of that inequality. So it's super important that you attend to precision. So we're going to give 3 solutions for each inequality. When it says solutions, it's asking what would make this inequality true. So again, just slow it down, attend to precision, and be an advocate. We're going to work through these together. So y is less than 11. Say it out loud, say it in your head. Either way, sometimes hearing it makes a light bulb go off. So y can be equal to 10. 10 is less than 11. Y can be equal to 3. 3 is less than 11. Y being equal to 12 is not going to happen. 12 is not less than 11. I could also use the number 9. That would work too. For number 6, p is greater than or equal to 100. So this one is one that's saying it could be 100 or it could be greater. So p could be equal to 101. That's greater than 100. I mean, it's only by 1, but it's still greater than. P could be equal to 200. That is greater than 100. Can confirm. P being equal to 100 is also true because this says greater than or equal to, so it can stay. For number 7, I'm looking for a product that is greater than or equal to 18. Now I'm going to have to multiply it by 3, so 3 multiplied by something is greater than or equal to 18. And I can use the space to the left or underneath, either way, to start brainstorming. Now if I try the number 1, 3 multiplied by 1 is 3, and that would not make that true because 3 is not greater than or equal to 18. I could do c is equal to 10, right? 3 multiplied by 10 is 30, and 30 is definitely bigger than 18. I could also do C is equal to 20, right? That is going to give me 60, and if I did 21, I will get 63. Both are much greater than 18. I could also do C is equal to 6, because 6 multiplied by 3 is 18, and this told me I could do greater than or equal to 18, so it can stay. We like that answer. And number 8, it is V plus 3 is greater than 6. So it's something plus 3 is going to give me a number that's greater than 6. So V can be equal to 4, because 4 plus 3 is 7. That's absolutely true. V can be equal to 12. 12 plus 3 is 15, and that's greater than 6. Okay, I mean, I could rock that. V is equal to 3. 3 plus 3 is equal to 6. Ooh, that one's not going to work. Now, 6, if this said 6 is greater than or equal to 6, it would work. This just said greater than, so it's not going to work. Now we're going to graph it. We're looking at a number line, and this is x is less than or equal to 2. I'm going to go right to the 2, and I'm going to put a circle. In this case, I'm going to fill the circle because it's less than or equal to. My arrow for my number line will be going to the left because 1 is less than or equal to 2. 0 is less than or equal to 2. I could also get into negative numbers, but we don't really need to do that right now. Number 10. W is greater than 6. So when I graph this, I'm going to go to the 6, and I'm going to put a circle, but it will not be a filled one. It'll be empty. My arrow will go to the right, and I could check my answer by saying, well, 7 is greater than 6, so is 9, so is 8, so is 10. Customers who spend $25 or more get free shipping. Let D represent the amount spent by a customer who gets free shipping. So if you spent $25 or more, you get free shipping. We're going to write an inequality to show the possible values of D. Remember, it's telling us $25 or more. So I'm going to write D, that's the variable they gave us, and D is going to be greater than or equal to, and it's going to be to 25. If they spent $25, they get free shipping. If they spent $26, they get free shipping. If they spend $300, they get free shipping. If they spend $24, you're going to have to pay. It has to be 25 and above. D could be worth 662. You're going to get free shipping. D could be 26. Going to get free shipping. So we're going to graph that same inequality, but on this number line. So I'm going to have a circle. Because it has an equal to, I'm going to fill it in, and my arrow will be going to the right to showcase all of the values possible.